The following are 6 different videos that walk through different assessments that the ACT math exam will go through. Each video will contain an easy, a medium, and a hard problem from a specific test in regards to each one of the categories. Let's start at the beginning though, so you kind of understand what the ACT exam will entail in terms of the math. The ACT math test asks you to answer 60 multiple choice questions and you get 60 minutes to do it. The questions are designed to measure your mathematical achievement, the knowledge, skills, and reasoning techniques that are taught in high school math, and they're needed for college mathematics courses. Therefore, the questions cover a wide variety of concepts, techniques, and procedures. Of course, some questions will require computation, but you are allowed to use a calculator on the math tests. You'll need to understand basic mathematical terminology and recall some basic mathematical principles and formulas. However, the questions on the test are designed to emphasize your ability to reason mathematically, not necessarily to focus on your computation ability or your ability to recall definitions, theorems, or formulas. And a lot of times they'll have you be working through using a calculator, but a lot of times it's just reasoning. Can you think through a process as to how to get the answer? Here's the content of the ACT math test. The questions on the ACT math tests are drawn from the following 6 categories, which are explained later in these videos. These 6 content categories represent areas of mathematics commonly taught by the end of grade 11 that are important to success in entry-level college math courses. The 6 content areas are pre-algebra, elementary algebra, intermediate algebra, coordinate geometry, plane geometry, and trigonometry. And they go in order from easy to most difficult. Basically, pre-algebra, which is going to be your 6th, 7th, 8th grade, to elementary, which is in your 9th grade, intermediate 9th grade, a little bit of algebra 2, coordinate geometry, which is generally 10th grade, which is geometry, and then your trigonometry, which you'll see in algebra 2, and a little bit in geometry as well. You will receive a score for all 60 questions and 3 subscores, a pre-algebra elementary algebra subscore based on 24 questions, an intermediate algebra or coordinate geometry subscore based on 18 questions, and a plane geometry trigonometry subscore based on 18 questions. A couple of key features to remember when you're taking the ACT exam. You don't get punished for taking a guess. And remember, all the answers are there in front of you in terms of multiple choice. See if you can narrow it down and get to a point where you're taking a 50-50 guess. Or sometimes it helps to read ahead. Sometimes you remember things as you kind of go back, go, oh, that's right, I remember that problem, and then go back to a problem that you weren't quite sure of. That's the way I would look through those. The following video is talking about pre-algebra, or is the content of pre-algebra. Pre-algebra questions involve solving problems using the mathematics that you probably learned before you took your first math course in high school. Things like operations using whole numbers, fractions, decimals, and integers, numbers raised to positive integer powers, and square roots of numbers, ratio, proportion, and percent, multiples and factors of integers, absolute value, ordering numbers from least to greatest or greatest to least, simple linear equations with one variable, simple probability, and counting the number of ways something can happen, representing and interpreting the data in charts, tables, and graphs, and simple descriptive statistics like mean, median, and mode. The following problems will include an easy, a medium, and a hard problem. The first problem we'll look at is number 3, which would be considered an easy problem. Shanika has a bag containing 50 pieces of candy, 6 strawberry, 12 orange, 10 lime, and 22 lemon. If Shanika randomly takes a piece of candy from the bag, what is the probability that the piece she takes is strawberry or lime? So really what we're interested in is the fact that they're strawberry or lime. So I'm going to go back, realize we're dealing with 50 pieces of candy. So if you have 50 pieces of candy in the bag, then you go in to draw out, you're at least going to be out of 50 for the denominator to the bottom. And we're looking at strawberry, where there are 6 strawberry, plus there are 10 lime. So we're looking at a total of 16 out of a possible 50 for the probability of getting strawberry or lime. Don't need to reduce. Look at all your possible answers here, and you'll notice that C is your best answer and it's not in reduced form. The next question in pre-algebra would be considered a medium type of question. It is estimated that each 4-ounce portion of a certain type of apple contains 60 calories. What is the estimate for the number of calories contained in a 15-ounce portion of this type of apple? I like to think of this as a proportion. It's two ratios that are going to be equal. You're dealing with 60 calories and 60 calories for a 4-ounce portion. Well, I want to know how many calories, we'll call it X, for a 15-ounce portion. So we'll call this as your ounce. And I want to know how many calories we're dealing with. When you set a proportion, solve for X by cross multiplying. So 4 times X equals 60 times 15. Or 4X is equal to 900. Divide both sides by 4. Whatever you do to one side, do to the other. So X is going to be 225. I would estimate that 15 ounces would be roughly 225 calories. Before you answer it, let's see if it makes sense. It went from 4 ounces to 15 ounces. From here to here it went up, so then my calories should go up as well. And it goes from 60 to 225, so I would say 225 is probably on the right track, and it is. Your answer is J. The next problem, or the third problem we'll go through under the pre-algebra category, would be considered a more difficult problem. Which of the following integers must be a factor of the sum of any 3 consecutive positive integers? In this scenario, you need to know some definitions. First of all, 3 consecutive positive integers. Consecutive means one follows the other. For example, 20, 21, 22. 3 consecutive whole numbers, meaning no decimals. Which of the following integers must be a factor? A factor means is divisible by. Divisible by, or can be divided into. So what I'm going to do is I'm going to focus in on the 3 last digits. If we add those, and I get 0 plus 1 plus 2, I get a total of 3. Let's try the next set. Let's try 21, 22, 23. Just another example. You can pick any numbers you want, just trying to set up a pattern here, which is what they're trying to test us on. Well, this would be 1 plus 2 plus 3, which is a total of 6. Let's try the next set. Let's go 22, 23, 24. Notice I just keep adding 1 to each of these. And this time 2 plus 3 plus 4, we get 2 plus 3 plus 4, or 9. And you can try another one if you want. 23, 24, 25. 3 plus 4 plus 5 is going to give us 7, 12 for a total. All right, I see a pattern developing here. We got 3, 6, 9, 12, and we can go back and look at these numbers and see which ones are divisible. Does 6 go into 3? No, 6 doesn't work. Does 6 go into 6? Yes. Does 6 go into 9 evenly? No. So that doesn't work. We don't need to keep looking at the 6's. How about 5? 5 doesn't go into 3 or 6 or 9 or 12, so I know that won't work. How about 4? 4 doesn't go into 3. 3 is not divisible by 4 evenly, so that doesn't work. How about 3? 3 divided by 3, 1. 6 divided by 3 is 2. 9 divided by 3 is 3. 12 divided by 3 is 4. I'm guessing 3 is going to be our answer. How about 2? Let's try 2. Just to verify, make sure we got all the answers, make sure you go and check all your possible solutions. 3 divided by 2 is not divisible. It gives you 1.5, or a decimal. So my best answer then is in fact going to be G. And you can also see a pattern developing here as well. 1, 2 increases to 3, 3 increases to 4 as you go through and look at the numbers. But I think in this case it's easiest to come up with, make up 3 numbers, then create another 3, and then a third 3, and then a fourth 3, and if you want you could continue it. But really what they're doing is testing, do you understand the definition of factor? Means divisible by, goes into it evenly, and 3 consecutive positive integers, which means 3 numbers, one follows the other, that's positive, and it's an integer. It's an actual number, no decimals to it. And then just seeing if you can develop a pattern. That gets us through 3 pre-algebra problems.